Let's imagine that we have a positive charge Q moving in this direction V. So the charge is moving that way. And let's imagine that it is in a magnetic field and the magnetic field is pointing up. We can figure out what the magnitude of the force is. We know the magnitude of the force is QVB sine theta. And sine theta would be sine of 90 degrees, or 1 in this case. What is the direction? The direction of the force is such that it is perpendicular to the velocity and the force is perpendicular to the magnetic field. What direction corresponds to that direction such that it's perpendicular to the velocity and perpendicular to the magnetic field? I want you to think about that for just a minute. Turn the video off so that you can spend a couple minutes and just think about it. The velocity is, say, in the x direction. The magnetic field is in the y direction. What direction would the force be that would be perpendicular to both the velocity and the magnetic field? Think about that for a minute. Well, I hope you stopped and thought about that. What direction is it? Well, there are two possibilities. Either out of the board, perpendicular to the board, coming out, or perpendicular to the board, going in. There is no direction within the plane of the board, this way or that way or this way or this way or that way, that is going to be perpendicular to both the x direction and the y direction. We have to go in the z direction or the minus z direction, either out of the board or into the board. To indicate those directions, from now on, I'm going to introduce two more symbols. And I want you to just imagine that you're looking at an arrow. If you see an arrow coming toward you, what do you see? An arrow is coming towards you. You see the point, or let's just say it's pointing towards you, not coming at you. It's pointing towards you. What do you see? You see the point of an arrow. So if you draw a circle with a dot in the middle, imagine that's like an arrow pointing toward you, kind of like this pen pointing toward you. This direction we will mean to indicate out of the board, or out of your page. If you draw it on a piece of paper, it means out of the page, out of the board, perpendicular to the surface in this direction. If the arrow is going away from you, pointing away from you, what do you see on the back? You see the feathers on the back, the fletching. Well, what does that look like? If you draw a circle and draw the feathers or the fletching on the back of the arrow, that will indicate a direction going away from you. So away from you. So this means into the board, or into the page, or whatever you're drawing it on, whatever you're writing it on. So which one do we want? What direction is the force in this particular case? To figure that out, we're going to use what's called the right-hand rule. The right-hand rule. This must be done with your right hand. Now, you might think this gives an advantage to right-handed people, but the fact of the matter is it's actually advantageous to left-handed people. And I'll explain why in just a second. But let's learn the right-hand rule. Oh, let me just mention that sometimes I will write this as RHR for short, for right-hand rule. When I was at college, we learned one form of the right-hand rule. Since that time, I've learned two more. They all give you the same direction. They all use your right hand. You can pick whichever one you want to apply the right-hand rule. They all give the same results. Some are, or one in particular, is a little more useful, or I should say a little easier to use in certain circumstances. I'll go through all three and you can pick whatever one you like. So the first one, take your hand, your right hand, put your hand up with your thumb and your fingers apart. And what you have to remember is the kind of the order of things. 1, 2, 3. So your thumb, that's the first one. Then your fingers are the second one. and then your palm points in the direction or pushes in the direction of the third. Remember, I asked you to, whoop, it's gone now. I asked you to remember, let me just write it down again. I asked you to remember F equals QVB sine theta. That QVB, that order is what's important. VB, VBF, VBF. So we point our thumb in the direction of V, our fingers in the direction of B, and then our hand will push in the direction of F. So let's try it in this case. So we want our thumb to point that way. So we point our thumb that way. Now we want our fingers to point upward. So I have to turn my hand up like this. Match my thumb and fingers with those directions. My hand then pushes this way, out of the board. So in this case, the force on this charge would be out of the board. Very good. In the beginning, when we started talking about this problem, I said, let's imagine we have a positive charge. That would be the direction of the force on a positive charge. If this were a negative charge, the force is in the opposite direction. You've got two things that you can do to figure that out. You can either use the right-hand rule, figure out the direction that would be acting on a positive charge, and then reverse it. So, right-hand rule, V, B, push out, but if it's a negative charge, the force would actually be in. So I'll just say this would be for a positive charge, and then it would be into the board for a negative charge. So that's one thing you can do. Another possibility is to use your left hand for negative charges. Right hand for positive charges, left hand for negative charges. So notice, V is this way, B is up, my left hand pushes into the board. So into the board for a negative charge. That's one thing you can do. You can do either one. Use the right-hand rule for a positive charge and then reverse the direction if it's a negative charge, or you can use your left hand for a negative charge. That is one of the right-hand rules. V, B, and then your hand pushes with F. Another possibility is to arrange your fingers, your thumb, index, and middle fingers, in a set of mutually orthogonal axes, like this. Notice that my thumb, index, and middle finger are all perpendicular to each other. And then you can do it any way you want. You can, wait, back up. I didn't mean any way you want. You can do it VB, and then your middle finger is F. You can say VB, and then your thumb is F. Either one is fine. So say V. We'll do it the same way as we did the first one. So V is this way, B is up, and then F is pointing out of the board. So VBF or VBF, either way. So if you do V this way, B, your middle finger pointing up, and then F out of the board that way. Either one is fine. The one thing you've got to be careful about is when you form your mutually orthogonal set of axes, make sure you do it with this orientation. This orientation does not work. This is not good. This is good. Bad, good. All right? Keep those in mind. This is the orientation you want for the right-hand rule. And then again, excuse me, if you want to use your left hand for a negative charge, you can do that. Make sure you do the correct orientation for V, B, and F. This way, not this way, this way. Okay? Good. So we've got two possible right-hand rules, V, B, F, V, B, F. The third one is actually the one that I learned when I was in college, and it was the only one that I learned. These other ones I think are a little more straightforward in some cases. The way I learned it was and I'm not suggesting you use this one, this is just the one I learned. You point your fingers in the direction of the first vector, V. You then rotate them into the direction of the second vector, which would be B. Your thumb then points in the direction of F. So I point my fingers in the direction of V, that way. But to rotate them into the direction of B, I have to put my hand this way so that I can rotate my fingers upward. Do you see that? V and then B, V, B. So that my thumb points out of the board, again, in the direction of the force. Likewise, for a negative charge, V, B, rotating it up, that would point into the board for a negative charge. So you've got these three possibilities. VBF, 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 either one will get you in the right direction. Now let me explain why this is actually advantageous for a left-handed person. Let's imagine that you're actually taking a quiz or an exam or something like that, and you are working away, you're working on a problem, and you come to a problem where you need to apply the right-hand rule. What do you have to do? Well, if you're a right-handed person, you have to put your pen or pencil down, you have to do the right-hand rule, you have to pick your pencil or pen back up and write the answer down. However, if you are a left-handed person, what do? You are writing along, doing the exam, you come to a right-hand rule problem. Oh, simple, you use the right-hand rule. Oh, there it is, and you can write your answer down. You don't have to put your pencil down or anything. And you might think this is ridiculous, but the fact of the matter is, unfortunately, I have seen right-handed students who are taking an exam or a quiz. Oh, here's a problem, I'll do the right-hand rule. But they don't do the right-hand rule, they do it with their left hand, and they don't even think about it. So you've got to make sure, when you want the right-hand rule, you've got to do it with your right hand. If you want the left-hand rule, you've got to do it with your left hand. Very, very good. Let's take a look at this actually really takes a little practice. Let's do some more examples. I'll just choose some arbitrary directions for V and B, and let's see if we can figure out what forces we would get. Here are 6 examples. Let's take a look at them, and I'll go through all 3 right-hand rule possibilities. So up here, for a positive charge with that velocity, that magnetic field, what's the direction of the force? You spend just a couple seconds, if you want, turn off the video and you give it a try. It's very, very important that you actually give this some practice and try it yourself. So see if you can figure these out. This one is a positive charge, velocity this way, magnetic field this way. This one is a negative charge, velocity this way, magnetic field, what direction is that? Into the board. This one, a positive charge, velocity, what direction is that? Out of the board, magnetic field up. This one, negative charge, velocity that way, magnetic field that way. This one, positive charge, velocity that way, magnetic field out of the board. Got that right? Is that right? Out of the board. This one, a negative charge, velocity, what direction is that? Into the board, magnetic field that way. All right, you give those a try and see if you get the same result that I do. Let's come back up here. Let's do the first one. VB. I'll do the first one for all 6, then I'll go through and do the second one and then the third one. So remember, VB. V up. One problem that people have with this is you've got to make sure that you physically get your hand in the correct orientation and make sure you keep your palm flat. So V, now B, whoa, I've got to turn my hand all the way over here. VB. For a positive charge, the force is out of the page. What about this one? V is this way. V. Now keep that one going that direction. Now I have to point my fingers what? Into the board. So I've got to turn my hand over this way so that my thumb points this way, my fingers into the board, my palm is pointing down, but it's a negative charge, so the force is upward. Let's actually draw these in. So the force, in this case, I would get up, and what did we get this one? VB out. And then what about this one? V is what direction? V is out of the board. So I point my thumb out of the board. I have to point my fingers up. So this way. What direction is the force? To the left. It's a positive charge. Force is to the left. What about this one? V, B. Ooh, wait a second. Wait, what? Oh, wait a second. What's the angle between these? It's 180 degrees. What's the force? Well, if they're 180 degrees, the force is 0. There's no force. One important point to keep in mind, remember the angle between V and B can be anything from 0 to 180 degrees. So when you're applying the right-hand rule, you have to imagine that you can move your thumb all the way up to almost 0 degrees. If the angle is actually 0 degrees, there is no force, so you don't have to use the right-hand rule. To 90 degrees, but then you have to imagine that you can actually stretch your fingers all the way up to almost 180 degrees. So you've got to imagine that you could actually stretch your thumb all the way so that it's pointing in the opposite direction. Not past this way, because if it were over this way, you'd actually turn your palm over. But you have to imagine that you could almost stretch your thumb to be in the opposite direction of your fingers, 179 degrees, say. But not in the completely opposite direction, because if the velocity were actually opposite your fingers, that would be 180 degrees, and there would be 0 force. So, what about this one? 0 force. Here, we've got V is this way. B is, what's that? Out of the board. So now my palm is like this. And how is my palm pointing? It's pointing down this way. So the force would be in that direction. How would you figure out what that direction is? Well, if this were, let's say, 20 degrees above the x-axis, good catch, this would be 20 degrees to the right of the negative y-axis. So you would have to know what's the direction of V specifically if you were going to figure out what's the direction of the force that would be perpendicular to that. Remember, the force has to be perpendicular to the velocity as well as perpendicular to the magnetic field. What about this one? We've got V. What direction is V? Into the board. Positive. Yes, positive. Okay. Into the board. V is into the board. B now has to point over this way. So I've got V this way, B that way. My palm points down, but it's a negative charge, so the force is excellent. Let's try the other right-hand rule, V, B. So I've got up here, V, B, this way, thumb points out of the board. V this way, B into the board, thumb points down, but it's a negative charge, so that means up, opposite direction. V out of the board, B up, thumb points to the left for a positive charge, left. V, okay, we already know 180 degrees, so that's 0 force. Here, V is up that way. B is, you need to kind of move around a little bit sometimes. V, B out of the board, thumb points down that way for a positive charge. There we go. And then here, V points into the board, B points that way. How am I going to do this? There we go. V, oops, sorry. Oh, there we go. There's a problem you've got to make sure that you avoid. You might get your finger, one finger, going the correct direction, but then if you move around too much, you got to make sure that you keep your original direction correct and not move it around. So I've got to get V this way. I have to come down here. B that way. V into the board. B that way. My thumb points down, but it's a negative charge, so the force is up. There we go. So that's the second method. Third method, V rotated into B, thumb points in the direction of F. So V up, rotate it to B, thumb points out. V this way, rotate it into this direction, so I've got to go this way and rotate it into the board. My thumb points down, but it's a negative charge, so the force is up. V is out, and I rotate it up this way, So my thumb points to the right for a positive charge. That's correct. Again, we know that one's 0. V is this way, and I've got to rotate it to out of the board. This way, my thumb points down this way towards me for a positive charge. V is into the board, and I rotate it over this way. For B, my thumb points down, but it's a negative charge, so the force is up. Phew! All right, very, very good. Applying the right-hand rule does take a little practice, and just let me emphasize a couple things I said. Make sure that you physically make your hand point in the correct direction. If your thumb needs to point that way, make sure your thumb points that way. If your thumb needs to point that way, make sure you turn your hand around so that your thumb points that way. And then the same with your fingers. Make sure you get those orientations correct. Very, very good. Let's stick some numbers in here and let's find some magnitudes and directions.